Right, guys. Pleasant good evening, everyone. Welcome, everyone.
Evening, sir.
Good evening.
Good evening, sir.
Good evening, sir.
Good evening, Zahin. Good evening. Hello, Dominic. Hello. All right. We are back at it again. Hi, Hans. Good night. Blessings. All right. So we are back at it again. Coming to the end of third week. Can you imagine? New Year just started. We've gone 3 weeks into the semester already. We're doing good so far still. All right. All right, so just a reminder, ladies and gentlemen, I will be giving you an assessment next week, next week, Wednesday. Yeah, next week, Wednesday, I'll be giving you an assessment. So saddle up for that. I need to know where you guys are at. It's going to be administered online, so you're going to log in and you will see the paper on the screen. I need to get the class time to do it. I'll leave it on live so that in case you have any questions. And then now I'm going to send you instructions for how to submit. Okay. All right. So tonight is Wednesday. And I'm assuming that where are we at? I think last week we were wrapping up volume and sect and segment and arc. Was that what we were doing?
Yes, sir.
So like somebody say yes for the person who go out. Is that what we were doing, guys?
Yes, sir.
Okay. All right. So let's go ahead and check our document and see where we're at. I hope everybody is doing okay. I'm a little bit tired. I had to put in an all night last night on my side to study, so I kind of feel drained, but I'm still pushing. All right. So it would be this document because today is the 21st, no so? So it should be this document right here. That would have been 7 days ago. All right. I will let you know what the topics will be, but more than likely it's going to be questions from what you've been taught. So just prepare to answer some questions that will require some critical thinking. All right. So I'm just seeing right here that we had started volume, right? So tonight should be the end of this topic.
Sir?
Yes, go ahead.
I'm not seeing your
dear.
screen.
You're not seeing my screen? Okay, thank you. So tonight should be the end of this topic. When we're done tonight, it should be the end. That means we're supposed to be going on to a new topic next week. All right, so we are going to start. Since as we're on measurement, I'm going to start geometry next week. All right, I'm going to start geometry. So one of my faithful students, whom we can rely on, can jot that down so that next week when we come, in case I ask you, which I will, in case I ask you, what are we doing, guys? You'll be able to tell me that we are moving on to geometry. All right, we're going to be talking about some angles next week. So for tonight, we are going to wrap up the topic of measurement. We've been on it for a while. It's been a journey, but you know we've been successful in completing the contents that are surrounded under the topic measurement, and all we need now is just some practice. All right. Yeah. Remember that we have our Sunday sessions as per usual. We want to use those Sunday sessions for our practice, right? You see those topics that we have left, you know, the algebra topics and the measurement, and you know, we want to do some practicing on those questions. So if you can do the best and try to, you know, take advantage of it, because kind of cheap in a way, $500 for 2 hours. we get that much places. Okay, I'll be in the waiting room. All right, Abby, you're in?
Yes, sir.
Okay, yeah. That's on Zoom. I see my lecturer using it. So I want to figure out
Sir, are we
how does he
supposed to
do
be
it.
seeing your
Some
screen
really
now?
nice Zoom whiteboard and see what's applied. Because you're not seeing it?
No, we're not seeing.
Okay, all right. You should be seeing in the next 3 seconds. So let us begin. So last week, right? Last week, as you can see, as I'm scrolling here, we can see all the data that we've had. We had a very elaborate discussion on sector, segment, and ARCA. We did a few questions. So like I say, it's just all of what you've been taught. It just requires a bunch of worksheets and we just work through them. So we started the topic of volume and we defined what volume was, right? As you can see here, that volume is defined as the total capacity that a solid can occupy, or what is inside the amount of space that is within a solid. All right. And we also mentioned that volume, the unit of measurement for volume, is either cm³ or it is in liters, right? And I gave you a standard formula for volume of any prism, which is V is equal to A multiplied by H, where A specifically stands for the cross section and H stands for the height of the prism. All right, and we did mention that height can be length depending on the orientation of the solid, and specifically A stands for the area of the cross section. We looked at the 6 main prisms, right? I didn't look at anymore because the others are not on the syllabus, but it's due to note that we have solids such as the cone, right? The cone should be on this list and I don't know why it's not here. So you can see the cube, we can see the cuboid, I can see the cylinder, I can see the triangular prism. We only discussed 4. Oh, only 4 we'll go through, right? Oh, I wonder what go on. All right, so we have to touch on the rest. I think that's where I paused last week. Guys, check your notes. Did I go further than this? Was something deleted?
No, we didn't.
Okay, all right. So we need to touch the rest. So the cube we said has a square cross section, and the cuboid has a rectangular cross section, and the cylinder has a circular cross section, and the triangular prism has a triangular cross section, which you can see right here, right? Now, the next type of prism that we're going to be looking at is the prism known as the trapezoid. Oh, I didn't write the title here. So let me just zoom up for you. So this one is called the triangular prism. That is TRIANG, triangular prism. All right, triangular prism. And then now, of course, we have up here the cylinder. I don't think I titled it. So this one is called the CYLINDER, cylinder. All right. So the names given to the prism is strongly related to the cross section of the prism. All right. So now there's another prism that you might encounter, right? You will see it occasionally, and that prism is known as the trapezoid, right? Trapezoid, P-E-Z-O-I-D, the trapezoid. And it's kind of self-explanatory if you wish to be honest, it's kind of self-explanatory. It is the cross section is a trapezium. All right, so let me just sketch it for you here. All right. So the trapezium, let me just grab my eraser here. Okay, here we go. So this is the trapezium. All right, that's a straight line here. Gonna come like that. Gonna come like that. Gonna just slide down like that. All right, then I'm gonna go across like that. A little bit bigger. And across like that. I'm gonna come like that. Then we're gonna put a little slant side to it right here. Let me just erase this one. This one doesn't look so good. All right. Come like that, like so. Right, and then now what I'm going to do is connect this. And then now I'm going to put a little back to it now. So I'm going to just put some broken lines here at the back. Give it that like a 3D feeling. Come like so. Right, and then we'll just come like so. Right, so that gives me my trapezoid. Right, that's what it's kind of like what it looks like. It's not drawn perfectly, but you get the idea that right here and here is the cross section, because the cross section is a trapezium. All right, so that's a trapezoid. Okay, so if you see that, you should be able to identify. And generally, guys, they normally tell you what the name is. It's not a case where you're required to really even know how it looks, because they normally draw the block and then they write above the block a bunch of information that says the wedge below represents a trapezoid. So they can't really tell you. All right. So that's going to be number 5. So we have the square with the rectangle, the circle, the triangle, the trapezium. Then we're going to be looking at, say, let me see that 1, 2, 3, 4, 5, and this one, the standard one here, is the cone. And let me just draw a little bit better. So the cone. Oh, wicked! We get one. Whoa, that's what I always wanted to get to know, guys. This one look nice. Chai. Oh my. Nice. Sweet. You know how long we want to try to draw something here? Oh my. Oh, it gone. Let's try it again, guys. Oh my. Watch ya. It now work. Look how it do. Come and get it sweet a while ago, guys. You don't see that? Nice. Look, sir. Come and get it now. I know it now draw. Oh Lord. Oh my, sweet me all again. All right, so guys, in our work, we get lucky and we get unlucky. So we're gonna just work with our traditional one, right? So work with me. So you go. I've been trying to draw that shape for how long now, you know? All right, so that's my cylinder. Wait, we're not draw this already.
Sir, is the cone you're supposed to be drawing now?
Oh, the cone is supposed to draw. I'm not sure. All right.
Yes.
All right, yeah. And that's an example of the cone. Not perfect, but you get the idea. Circle at the top, that's the apex at the bottom. All right. So this is the cone. Okay, that's the C-O-N-E. Now we're not going to draw the rest of them because we're not going to do them. See what I'm saying? We don't need to know them, right? The other ones are the pyramid and the sphere. So it's 8 of them. So for now, we're just going to look at these 6. All right. Now it's a lot of prisms, right? I can agree. It's a lot of prisms. So the temptation, or probably the idea that you guys have is like, oh, so you have so many prisms. Do I have to know all these formulas? No, you do not. No, you do not, guys. You do not have to know all the formulas for the prism, right? The only thing you need to know here, ladies and gentlemen, is what is the main formula, right? And so the main formula for the prism is that volume is going to be equal to A multiplied by H, all right? And that's the formula that you want to, you kind of want to right? So you want that formula. V equals A times H. All right? Now, it's very important for you guys to not only remember that A represents area, but A represents the area of the cross section. So when you look at the prism and you are unable to tell me what shape makes the cross section of this prism, you're going to find a challenge. Right? You're going to find a challenge because it's the reason why we went through all of this. Now look at this. It's a reason why we went through all of this up here. Now. The moment that we are talking about area of see there, area of triangle. Remember all them something we're gonna do? And then up here, so we talk about the area of this and area of that. All of these formulas, all of these discussions up here are gonna come into play. Rectangle, circle, all that is gonna come into play. So we didn't just go through those because I like to teach math. I go through those because we're going to eventually use them back. So now, let's look at an example of what I'm referring to now, guys. Let's look at an example of what I'm referring to. Okay? This is how we derive a formula. So I have this block here, right? This cylindrical container. We're going to call it a drum. Right? We're going to call it a drum. I like how that one look. All right, so I have this cylinder right here, right? Boom, boom. And let's call it a container that has some water in it, right? And I want to know, let's say it has some water in it, right? So it has some water in it, right? But I want to know how much water is in it. Or, in fact, I just want to know how much water can it hold. By using the formula V equals area times height, it's very evident that the base of this container is circular. So if I know that volume is equal to area times height.
Sir?
Yes?
Sorry, but one of your students got kicked off. They're in the waiting room.
All right, thank you. All right, so if I know, let me just, I don't want the page to refresh, you know. That's what I don't like. All right. All right, so if I know that volume is equal to area times height, then all I have to do is to figure out what kind of shape does the base have. And it's very evident that the base of this shape has a circle. So we would have had some knowledge about circle from the last class. And that formula would have been pi r squared. And it would have simply multiplied by h. And that is how you derived your volume formula for a prism. Now, let's just say hypothetically then, I call this side 25 centimeter. And let us just say from the center of the base to the edge, which is the radius, I'm going to call this radius, say, 6 centimeter. The radius is 6. That's the measurement given to you, right? So the radius is 6 and the height of the cylinder is 25. How could I calculate the volume of this prism? I would simply then say that volume is equal to, we already know that pi is a constant and that value doesn't change, so that's 3.14. And I look on the diagram and I realize that the radius is 6, so I'm going to put 6 squared here. I'm going to times it by the height, which is 25. Go ahead and process that mathematics there for me and tell me what number comes out. .14 times 6 multiplied by 6 multiplied by 25. This number will represent the volume of this particular container we're looking at. Talk to me.
I am seeing 2,826.
Point or no point?
No point.
Centimeter cube. And that is how you find the volume of this cylindrical container, right? Now, let us just say then that they wanted you to write the answer in liters. If they want you to write it in liters, what you do is just shift the point 3 places backwards. So the answer is going to be that the volume is equal to 2.826 liters. So if it's in centimeter cube, it's 2,826. But if you want to write it in liters or you want to round it off, you can just say it's approximately equal to 2.8 liters. A little bit more than 2.8, but we're just rounding it off to 2.8 liters. All right? And that is how you find this particular prism. Okay? Now, let's do another one, right? Because we know several of them. So I'm trying to do the hardest ones, right? Or the ones that I think might be most challenging, right? So let us do the triangular prism, right? Let's do the triangular prism. So I'm going to draw this one here. Yeah, not perfect. Didn't connect, but I'm going to try. Right. So here's a prism that I'm drawing. And you can agree that that's a triangular prism, yes? Because the face of the prism is a triangle. Now, we already know that there's different types of triangle. And if there's different types of triangle, then it means that this triangle is quite sensitive to the type of triangle that is there. Now, I haven't given you any information about the triangle, so I'm going to give it to you now. I'm going to call this side 5 centimeter. I'm going to call this side 7 centimeter. And I'm going to call this base down here, let's call it 10 centimeter. And then what I'm going to do now is that I'm going to drop on a length, right? Because the prism is lying down, so I'm going to call this length 18 centimeter. And that will look on the paper. And the question then says that we should find the volume of the block. We use words like block and wedge and solid and prism. Those words, they're all synonymous, right? So you want to find the area of the block, this wedge, right? Now, the formula doesn't change. The formula will still remain as being V, pardon me guys, V is equal to A multiplied by H. Now again, A still stands for the area of the cross section. But if we recall a formula that we learned, it starts with H. Can you tell me what it is, guys? Volume is equal to the A here stands for the area of the triangle. But this particular triangle isn't just, it's a special type. And it requires a special formula. Can anyone recall what that formula might be?
Half base times height.
All right, so we don't have any height, so we can't use half base times height in this case. The area of a right triangle is half base times height. But what is the area of a triangle?
The square root of S.
So it is a short, you can call it. Give me the name of the person.
Heron's formula.
So we're gonna use Heron's formula, right? Because we know where Heron's formula being. So I don't want to write it out and make the formula look too complicated. So I just write Heron's formula times H. All right. So this would be our formula for this particular triangle right here. That would be the formula. Let's go ahead and find it. No, can we go ahead, Miss Gentles? You were just saying to me, right? We need to find Heron's formula. So what is Heron's formula? A is equal to, and remember, I know you don't have to study this formula. No, it comes on the exam paper. So just skip the page and look.
The square root of S, bracket S minus A, close the bracket, S minus B, open, close, S minus C.
But we need to find a value. There's a particular value we need before we get to A.
We're gonna add all the 5, 7, and I'm not sure if
So
that's
A
10 or
plus
16.
B plus C divided by 2. So what would the A be and the C be?
The numbers on the sides.
Right. So that would be 5 plus 7 plus 10 divided by 2. Not true. All right. And what would be 5 plus 7 plus 10?
Okay, 12. 22 over 2.
Which is equal to what?
11.
Correct. So now we're going to take this 11 right here, right? And we're going to replace the values of S here, S here, S here, and here with 11. And put back the A, B, and C values that we had initially used back in the A, B, and C position. So remember, we have to find the A value first. You know? So we're going to say now that area is going to be equal to the square root of 11, open bracket, 11 minus, we said A was what? 5. And that's going to be 11 minus 7. And that's going to be 11 minus 10. All right. Now, what does bracket implies, ladies and gentlemen?
Multiplication.
Very good. So that's 11 bracket, the result of what is inside. That sounds like 6, right? Multiplied by 11 minus 7 is what? 4. And 11 minus 10 is what? 1. Not true. So now we are looking at 11 times 6 times 4 times 1, which by my calculation, that sounds like 264. Confirm, please. That was a mental calculation, guys.
Yes, sir.
All right, so I'm right. Very good. And what's the square root of 264?
$16.2.
16.25.
16.2? So 16.25. All right, so 16.25. Lovely. And then now, once we have that now, we can go back to the main formula to say that volume is equal to, we don't use Heron's formula, and we end up getting what? 16.25. And we know that the height is what? 18. Multiply that by 18, please. And would have gotten the volume of this block.
This is 292.5.
How much you got?
292.5.
292?
Yes, sir.
It says
292.
16.25 times 18.
Yeah, 292.25 is it right?
Just 0.5.
Or 0.5. I'm going to put that as centimeter squared. Centimeter cube, sorry. Centimeter cube. And that is how you find the volume of that particular block. So depending on the type of block, the calculation may be short, as in example number 1, and the calculation may be a little bit longer as it relates to our, for example, like number 2. So again, the formula for finding the volume of a block is heavily dependent upon the type of cross section it has. Let's try to do another one. Let's do another one. All right. Let's do another
Sir,
one. Yes, dear.
in an exam, how many points will a question like this value?
Well, this one up here would value 2. And the one down here would value 3.
Okay.
All right. So let's go up here and use our shape that we have up here then. Right? So let us evaluate now and try to find the volume of this block up here. Right? This trapezoid that we have right up here. Since as I draw it already, I don't have to draw it again. Right? So we're going to look at that trapezoid right here. Right? That one right in front of us now. All right. So again now, we know that volume is equal to area times height. And recall that A doesn't just stand for the area, ladies and gentlemen. A stands for the area of the cross section. So if you cannot figure out what type of shape makes the cross section, then you're going to be stuck. So when we look at this block here, even if I did not tell you that it's a trapezoid, the fact that it have one arrow here and one arrow here, and then you see there's a 90-degree right here, you're going to see them, you know. I didn't draw it this time, but you're going to see it. There's a 90-degree there, a 90-degree there. You can see that it's a trapezoid. All right. Now, can anybody recall what is the area of a trapezium? I think we had discussed this in class. Can anybody recall that formula?
Yes,
No,
sir.
sir, we didn't get that.
You sure?
Yes, sir.
Sir, someone said they're in the waiting room.
Okay. Zahina got kicked out.
Sir, because I don't
All right, so we
even
didn't get that.
know how that thing is drawn. The
We don't know how it's
trapezium.
drawn.
I'm not sure.
Trapezoid,
I'm not
trapezium.
sure. Yeah, I haven't seen it. I haven't seen it in a while.
All right. We're going to look at it then. So the area of the trapezium is going to be A plus B times H divided by 2, and again we times the result by this H on the outside. All right. So let me show you where the A, B, and C is. Let me grab a different color ink to show you where the A and the B's are. So the A and the B now, watch me now. The A and the B now. The A would be up here. the B would be down here. The small h would be at the back right here, and the other h would be right here. So we're going to call this H2. We call this H2. That's H2. We're going to call this H1. So the first H is the height of the trapezium at the side. And the second H is the height of the block, which in this case is a length because it's lying down flat. All right? So that would be the formula. Good thing is that the formula comes on the exam paper. So my apologies, guys, if I had gone through all the shapes and I forgot to do the trapezium. That's very unlike me. But I guess maybe because we took a pause at one point and then we came back to it. So maybe that's why I forgot. But my bad. So let's see here. Volume is equal to. All right, so I'm going to put some measurements on here for you, right? I'm going to put some measurements. I'm going to put them on the other side, guys. I'm going to put them. So I'm going to call this side 3 centimeter. I'm going to call down here 5 centimeter. I'm going to call the side, the back here 2 centimeter. All right, and then I'm going to give the height of, say, 13 centimeter here. Oh, bring it back. Where did you go? Okay, thank you. All right. So that's going to be 13 centimeter. All right, so in this case, follow me, guys, and tell me what I should plug into the formula. Since as I told you what A, B, and H is, tell me what I should write down over here. A is what? Talk to me now, guys. What's
A plus B over 2. That formula that right up there, so sir.
What? So this number up here is what?
That formula right up the V formula. Then you multiply that by it.
Yes, are the numbers them one or not? Tell me the numbers them now.
That's 34.
Oh no, sorry, it's 3. My bad. All right, ugly. 3 plus what? Number at the
The other
bottom.
one is 2.
At the bottom.
5.
5 divided by 2. Right? So put this number bracket here, so. Times what the one at the back is. Right? Ugly, not 2, or 2. And then I times it by H, which is 13. So if you compare, this number is A, the one at the back is 2, the one at the bottom is B, and then the height is right here, right there. All right, so let's go ahead now. Go ahead and add 3 to 5. You can cancel out them 2s still, you know. If you want, you can cancel them out. So go ahead and say 3 plus 5 and times it by 13.
It's 104.
All right, 104.
5 and 3, 8. So 8 times 13, 104.
It's 104, yeah, man. So you're good, I hit that. So the volume of this trapezoid right here, based on the measurements given, is 104 cubic centimeters. All right. So that's the basic idea. Like I said, it's the basic idea of how to find the prism, right? The rest of them is kind of more or less the same. You just have to ensure that you are familiar with the formula for the different prisms, right? So so you can find the one for the rectangle, length times width times height, or the one for the cube, length times length times length, which is length cube. And we can go all day, all night. This one's a little different though, right? This one I think CSEC normally give you. But this one is and I don't really want to go into it too much, right? I don't want to lose the essence of the class. But this one is another day, another time, when we have more time to like go in depth. We can look at why the formula is going to be V is equal to Device is freezing. V is equal to, all right, guys, yeah, man, the device start up itself now. And decides I'm tired of me. Knock out a normal. So I'm gonna just freeze up here. Any questions so far? So let me show you how to derive the formula, you know? And I also show you how to work 1 and 2 little question, right? Of how to find the volume, but it's deeper than that, obviously. It's very much deeper than that.
Well, I'm not so clear on the trapezium part.
Yeah, well, yeah,
But
well,
I guess I'll get that later on.
yeah, man. Eventually you'll get it. You'll catch on to it. You'll be like, oh, okay. So that's what that's what I understand. Yeah, man, you're gonna catch it. It's just that maybe because I haven't gone through, like maybe that's where the blurriness is coming in. All right, we'll get there. Now, before I move on to the other phase of this, which is going to be total surface area and surface area, right? I'm going to show you a little question, right? I'm going to show you a question. And this question is more like a little introduction to the applied versions of this, right? It's kind of like a real life question to an extent, right? It's a question that we don't usually ask ourselves, but it come up and we just kind of just use estimation to figure it out, right? All right, so it's a rhetorical question. I'm sure that you've held a bucket in your hand, right? And when you hold the bucket in your hand, the bucket is kind of half full, 3/4 full, or maybe there's a bit of water down into the bottom, right? So let's say that this prism here, watch what I'm going on now. Focus with me. I don't know what is this, you know. Try. All right, so. Why is it not straightening? Pardon my drawing, guys. Pardon my drawing. I'm not the best artist in the world. And just do a little thing, you know? A device decides, you know what? Your students might learn too much, you know, so you know what? I'm going to interrupt your little speed. You're teaching too good, Mr. Pierce. You know what? I'm going to slow you down a little bit. You know, some students are patient. Very patient. All right. All right. So in a draw, 100%, right? In a draw, so wonderful, but you get the idea. Not true? So here's what I'm going to do now. I'm going to pour some water into this. Right? Hold on. Let me put some measurement on it. I'm going to call this 36 centimeter. Right? And I'm going to tell you that the radius of the base, right? So the radius, you're always going to be told what the radius is. So the radius of the base is going to be 11. Now appreciate 11. So the radius of the base is 11, right? And the height of the container is 36. That's how tall it is, right? So I'm gonna pour some water into it, right? Let me just get red for water, or no, blue for water, right? So I'm going to pour some water into the bucket, right? And so the water is going to reach at a certain height. So we're going to say that the water reached about here, so. You can't guess, you can't say it looked like it halfway, We don't know, right? So I'm going to pour some water in here, so. And it sort of looked like it halfway, but as I said, you cannot guess. So I'm going to pour some water in this container. And so when you pour the water into the container, it don't, reach, full it. So we have a certain amount of water that the tank can hold, and we have a certain amount of water that is actually in the tank. So therefore then, watch this now. The tank has a height. Agree? And the water also has a height. So sometimes you get a question that asks you to find perhaps say the height of the tank, and then the question might come in a look a funny way and then say find the height of the water that is in the tank. Now I'm going to structure the question here. All right, so I'm going to pull out a little notepad and I'm going to make the question more doable. Okay, here we go. The container below is in the shape of a cylinder. Or I shouldn't write it like that because it's not a shape. That doesn't sound right. Better yet, the cylindrical container below Okay. All right, guys. I don't know when you see that, you know what that means, right? It's acting up. I'm going to go with himself.
Sir, why not just dictate in the meanwhile?
Oh, yeah. All right, so the cylindrical container below has a height of 25 centimeter. Or 25 did put or 36? And remember?
36.
Right. So this, thank you so very much. So the cylindrical container below has a height of 36 and a radius of 11 centimeter. And a radius of 11 centimeter. Full stop. Hold on. I need to do a quick calculation before. Give me a sec. Give me a sec. I'm not tell you foolishness, you know.
Sir, I'm not seeing what you're working out,
I'm not working out anything, you know. I'm gonna try to load the screen. I'm dictating in the meantime.
The internet is unstable.
You're seeing my screen, right? Awesome. And my internet, that's the app I use. The app is a lazy app. All right, it's coming up, guys. It's coming up. So let me do a quick little calculation there before me telling the foolishness. All right, so this is gonna be 3.4 times 1 times now times 6. All right, so we'll go so 1, 2, 3. All right, so I'm gonna say, all right, so ready? 0.6. All right, ready. So the cylindrical container below has a height of 36 centimeter and a radius of 11. Full stop. It currently holds 9.6 liters of water. It currently holds 9.6 liters of water. Full stop. Use the information. Use the information to calculate the height of the water. Use the information to calculate the height of the water. All right. So it's one of those type of questions that, you know, you kind of see it and you be like, all right, how do I start this now? Like, me remember Mr. Peter teach me this now, but I don't know how to write it down. You start, ladies and gentlemen, I think I posted a video on my TikTok page today, you know? And I'm so glad I posted it, because one of the things that I told you in earlier classes is when you get questions of this magnitude, where you know it's kind of challenging, the first thing you want to do is to write down a formula that's associated with the question. And this question is a question that is directly related to volume. So even if you're not really sure what to do, you know, so the first thing you need to do is to make sure you write down the formula for volume. And then you start to replace those letters with some numbers. But before we even do that, right, we know that volume is equal to area times height. And this particular container is a cylinder, which means that the cylinder has a circular base. So therefore then, we're looking at the fact that A is equal to pi r squared. And then times it by h, and then that's equal to v. All right. So now we have a formula working with. Now, very careful now, you know. I didn't ask you for the volume of the container. Nor did I ask you for the volume of the water, because you were told that the water inside the tank here is equivalent to 9.6 meters. So this is 9.6 liters. Now we have a problem because the measurement or the dimensions of the container is in centimeter, but the amount of water that is in the tank is in liters. So the easiest thing to do here is to convert the liters to centimeter cube. So how you do that? It's quite simple, right? 1,000, write this down, 1,000 cubic centimeters is equivalent to 1 liter. That's a very simple rule. So 1,000 cubic centimeters is equivalent to 1 liter. And at the moment, there is 9.6 liters in this tank. So therefore, the conversion for this is simply going to be that 9.6, so 9.6 liters is going to be equivalent to, I'm going to multiply it by 1,000. 9.6 liters is going to be equal to 9,600 liters, centimeter cube. When you multiply 9.6 times 1,000, you're going to get 9,600. Don't know what's going on. 9,600. All right, I can promise you this, guys. I'm not using but this app again. I'm going to use the whiteboard and Zoom. This app is stressing me out. I have to be refreshing the page too many times. So even though I'm touching it, like it's not reacting. All right, so confirm that for me, please. In the meantime and in between, between time. 9.6 times 1,000. Guys, are you here?
Yeah,
Yes,
break up.
sir.
Yes, sir.
Yes, sir.
Yes, sir.
So no answer me. And leave me alone by myself. I'll do with that. So it's 9.6 times 1,000, 9,600.
Yes,
Yes,
sir.
sir.
Hello, so why not answer me? Hello, if you answer me,
Kind of break up, so
because I
that's
already
why.
know
So
this.
you saw my break up.
So like me teach myself. I'm not hearing that person. It's like you're using
Sir, you're
data.
breaking
Sir,
up.
is you breaking up, sir?
Not hearing you at all, sir. Oh, I mean, I break up or not break up? Which one?
Tim is going in and out. Yes, so you are the one who is breaking up.
No, I'm just hear you loud. I got him say me and the one breaking up. My Wi-Fi is quite good. I'm
Something wrong
sitting
with
near
your
my router.
system.
I don't know what's going on.
Something is happening though.
Must have been the persons have been talking to you and you're not hearing.
Oh, come Vix, you know. Vix. There was some more long.
Yeah, the Victor and that's your fault. Your system.
But me say this, I'm not using this app again. It's a good app, you know, but boy, me I tell you. No, sir. Stress me out, man. See there? I'm trying to zoom up and see there. It's not giving me anything. I've been experiencing this also on my lecture classes too, you know. Right? I've been experiencing this too. I have a hard time seeing what my teacher is writing when I'm at school. All right. So anyway, I'm gonna try to see if we can dictate it until this thing starts to give me some justice. So for me now, guys, based on what you should have on screen, you should have underneath
You're not
V,
seeing the
please
screen.
write for. Oh, you're not seeing? All right. So yeah. So underneath the V, so the formula that we had written a while ago, underneath V, please write 9,600. And then you're gonna write equal. Write down the value for pi. Times. Write down the radius value. So that's 11 squared. And you're going to write times h. Because h is what you're looking for. Sir, how if you look for h and h is 36? No, 36 is the height of the tank. I'm looking for the height of the water. And I already wrote down that 9,600 cubic centimeters of water is in the tank. All right, now go ahead for me now until this thing pulls up, guys. Go ahead for me now, ladies and gentlemen, and multiply 3.14 times 11 squared.
379.94.
And then you write times h beside it, right? Times h beside it. Now, you're going to go ahead then now and divide the number on the left, which is the 9,600, by the number you just told me a while ago, which I don't remember. You talk so fast. So go ahead and divide 9,600 by the number that you have on the right, and then that should tell you the value of the height of the water. You have to get a number that's less than 36.
25.27.
It's going to be more than 18, but less than 36. Talk to me. What you got?
25.27.
All right. So that's your answer, guys. That is your answer. So the height of the water that is in the container at the moment is 25 point whatever you just say. And that is how you do that calculation. So a small little question here. Nothing too testy, you know? Right? Just to show you a little application question. Not major. Right? Not major. All right, so that's the idea. That's a basic application, right? But we have to meet up on these things to deal with them because the thing is that, you see, for exams, is like I've taught this thing for so long. I've seen years where I spend a lot of time on that topic and not even one of the question don't come. On topics that I feel like, CXC now send that come here on Monday, probably we might send it and then we not really put emphasis on it. You know, when she said, look, they send one question like just like that when I say me I got ignore. So what I do is in my classes, I just kind of touch the surface of things. I touch the surface of things and then I move right along. And then when we meet up on the questions, then we just use the tools and solve them. All right. So we're going to go ahead then and we're going to move on to the last two things that I want to touch base on. I just kind of want you to see it. All right. And so the last two things we're going to touch on for this topic and for tonight's class, it is going to be what is called total, pardon me. First, write this down, guys. Surface area, put in bracket S dot A, and total surface area, put T dot S dot A. So the topic is going to be surface area, in bracket S full stop A, all capital, and total surface area. In bracket T dot S dot A. Now it's an online class, so I don't really have the resources to kind of show you visually what this is. So I'm going to use a diagram and kind of explain it as best as I possibly can. So what do you mean, Mr. Peart, by the total surface area and the surface area? I'm going to use a cuboid to do this explanation for you. So give me a few. Let me draw my cuboid here.
So one of your students got kicked out again.
So that's the best that I can do. Come device decides, you know what? I mean, I make students and learn no more. They might get too bright. So I'll give you some problems. But anyways, pay attention to the areas that are going to be called the total surface area. Sorry, the surface area. Now, when we mention the word surface area, let me give a title, right? I need a title. Surface area. I don't know if it's even writing. My lord. I was doing so good earlier. I don't know what is happening now. All right. Anyways, the topic is surface area. So the surface area is going to be this section, guys. Pay attention. Look at where I'm shading. For this, I'm shading the back. I'm shading the back of this. I'm shading the side. So the red strokes that you see I'm doing here, one is at the back, one is at the side. I'm shading the front now. This is the smartest thing to do was to just draw a line though. As now it cover the whole diagram. I know, hold on. I wonder if Google can help me. Because I really don't want to mess this up, you know. So maybe I can look at the total surface area. All right, so let's type it in and see if we can visualize it. So surface area and total surface area of a prism. I'm going to click on the image. All right. All right, so I'm not sure if I can see it. Let's see if I can find one that makes sense. All right, so we look at this one. And then this one will work. I don't like that one there, no one. So it's challenging to see it from this point of view, you know. It's kind of hard. It's when I'm in person, it's so much easier to explain. All right, so that's not going to work. Oh. A difference. Hold on. Go ahead and use the whiteboard and zoom and see what happens. Oh, so this is the whiteboard that I see my teacher using. Okay, all right. Let us see if it works. All right, guys. So, okay, it's working. Oh, wicked. All right. Guys, we're back in business now, man. Yay. Nice. Okay, guys. So we can start using this board. One sec. We all right?
Yes, sir.
Yes,
All right, yeah, man. I'm glad, man. Finally. Also, this is what my instructor uses. I didn't know, you know. All right, so watch now. Ready now, guys. Be nice now, man. Yes, so nice now. So look where the cross section be now. Right? The cross section is at the back. I'm going to kind of try shade it. And let's do the side first. So the cross section is at the side plus the other side plus the front plus the back. So the surface area is going to be the back plus the side plus the side. We're going to use letters and name it. So the cross section is going to be A plus B plus C plus D at the front. Leave out the top and the bottom. So A, which is at the side, B, which is at the back, C, which is at the side, and D, which is at the front. When you add those four shapes together, you'll get what is called the surface area. Now, so let me just write that down. All right. So surface area is going to be equal to A plus B plus C plus D. So that is what we call the surface area. Now it's kind of because what if the prism don't look like that, sir? All right. So there's a formula, right? And the formula, ladies and gentlemen, is that surface area is equal to the perimeter of the base times the height. So the formula is that surface area is equal to perimeter of the base times the height. All right. So basically what you do is the shortcut for it, right? Instead of finding the area of the side and the area of the back and the front, we just simply find the perimeter of the base, which is the distance around here. Let me just grab a different color. So what we're going to do is find the distance around here, this, plus that, and times it by that. So you're going to add up the edge around the base and times it by the height. That is how you find the surface area. All right. Now, what's the total surface area now? The total surface area, right? Can't I get rid of this? Okay, yeah, I can get a bigger space, right? So what is the total surface area now? Forgive me, guys, I don't know the features on this. So forgive me if you see I'm moving a bit slow. All right. Because I'm using this board. All right, so what's the total surface area? Let's draw about the prism again now. What's going on here? All right, so let's draw about the prism again. Is somebody writing on my board? Because so I erase it, I see somebody writing on the board. All right. All right, so that's my prism again, my block, right? So now, where is the total surface area? Hold on. Is there somebody writing on my board? I don't know, this last part of my class is messed up. So I don't know what is all of this extra stuff here. All right, so let's try this again. One last time. So now, the total surface area is going to be A, which is at the side, B, which is at the back, C, which is at the side, and D, which is at the front. And then now I'm going to add on the top here. So I'm going to add on E and F. So E now is at the top, and F is now at the bottom. So that's the total surface area. A is at the side, B is at the back, C is at the side, D is at the front, E is at the top, and F is at the bottom. That sounds complicated to find, but there's a formula for it. So here's the formula then. Total, okay, total surface area is going to be equal to the surface area, which we found already, plus 2 times the area of the bottom. Because the area of the bottom down here is the same thing as the area of the top up here. So all I need to do is just, since I already know what A, B, C, and D is from the previous question right here, to add the top and the bottom, I just find the area of the bottom and multiply it by 2. So these are my 2 formulas, right? Sadly, how do I undo on this thing? I don't even know how to use this feature. Okay, undo is down here, right? So sadly, that they do not give us this formula on the exam. That's the only sad thing about it, right? So this is the formula here, right? Okay, all right. Let me find an example because it's 8:28, but we can squeeze in one example. Okay, let's squeeze in an example. An easy one. So we're not coming back to this next week. All right, we only go book up this one practice.
This here can go back up to the formula, please.
Oh, the formula? Oh, all right. Give me a second. Why do I feel like somebody's writing on my screen? It feels so weird. Here you go. I feel like somebody's actually writing on the screen, but I can't say for certain. Because these weird looking marks that are here usually means that somebody's on the screen or somebody's touching the screen. But I'll change the feature next time, so it's fine. All right, did you get it? Do you have it? All right, cool. All right, so let's do a quick example. I know it's 8:30. I'm tired, you're tired, but we have to try. Okay, because we're having some issues, but it's a part of life, is what I'm saying? All right, here we go. I need to practice how to use this thing, you know. All right, so here I have a height of 12 and I have a radius of, let's call the radius, I don't know, let's call the radius 4 centimeter. So the radius is 4 and the height is 12. And the question is asking us to find 1, the surface area, and 2 is asking us to find the total surface area. Now, I'm certain say somebody arrived on my screen. Guys, if you're doing that, can you please stop? If somebody's doing that on purpose, can you please stop? Because my device is not freezing, so somebody has their hands writing on the screen. All right, so quickly, not take too long. Now rush it, but me not take too long. If I want to find the surface area of this prism, right? I know from the previous formula that surface area is equal to P times H. All right, anybody can tell me what P represents?
The perimeter?
Right, and it would be the perimeter of where? Let me grab a red marker. It would be the perimeter of around here. What is the perimeter of this shape called? Start with C. What is the perimeter of a circle called? Start with C.
Circumference.
Circumference, very good. So therefore then that would be equal to 2 times pi times r. And then times that by h. All right, so go ahead now. 2 times what is pi? 3.14. And the r in this case is 4. And the height of this thing here is 12. Go ahead and punch that on the calculator.
$301.44.
301.44.
Yes, sir.
All right. Where's my board? I'm so uncomfortable. I'm not used to this app. These things are popping up all over the place. I don't know what's happening. Okay, there we go. Existing board. What's going on? How much say it? 301.
0.44.
Okay. All right, that down. That's the correct answer. All right, and then now for the total surface area, which obviously you're not seeing. I just don't know what's going on, guys. I've been struggling all night. Share this meeting. Share me all boards. All right, so this board right here. Open the board. Where is it? All right, guys, it's not showing up. All right, so I'm going to try to dictate. So total surface area now is going to be the answer you just got. So total surface area is going to be equal to the answer you just get. I will write it down. Plus 2 times. Now, the base of this prism here, as we could see, is a circle. And the area of a circle is pi r squared. So it's going to be 2 times pi. So 2 times 3.14 times 4 squared. Times 4 squared.
$401.92.
And that is your total surface area. All right, that's it. All right, not the most productive class, but I guarantee you that when I meet this thing again, right, when we actually have a question, I'll make certain that it's a lot clearer. Okay, but we've gone past our time. I'm very tired. So are you. So I'm going to close off the session for today, although we're struggling at the last part, but we got through it. All right, but that would be the end of it today, guys. Thank you so much for joining. I will see you guys next week again. Remember, start prepping up, start running back through some questions. I'll let you know what the assessment will be on over the weekend because I should be finished writing the paper by then. All right. So until then, be safe, be blessed, and we'll talk next week. Bye-bye.
Bye,
Bye,
sir.
sir.
Thank you.
Bye, sir.
Night.
Bye.